Hello, this is Mrs. Herzog coming to you with lesson 2 for week 2, and this is going to be on the ideal gas law. Now, what I suggest is that you not only watch this video, but also have the copy of the slides open as well, so that when I ask you to go do an Edpuzzle or go to a link or to watch a video, you're able to pause this, do that on the slideshow, and come back. Okay, let's start here. First of all, this is lesson 2. It's competency number 3. So at the end of this lesson, we expect that you are able to solve problems using the ideal gas law. Now, if you remember from the previous week's lesson, there are 4 variables that we use to measure a gas. The first being volume, V, and it's the amount of space a material occupies. The units are liters, milliliters, and centimeters cubed. If you would need to convert between those, the conversions are listed at the bottom of the screen. The second variable is pressure, designated capital P, and it's the force on a given amount of area caused by the gas particles colliding with the walls of their container. Now, if you recall from the previous lesson, temperature, if that is increased, the average kinetic energy of the molecules is increased. So they're moving faster and they're going to experience more collisions. That's why we have speed limits. When they experience more collisions, they're going to bang into the walls of the container. That's pressure. So as we increase temperature, kinetic energy increases, the number of collisions increase, and the pressure increases, which are all directly related. Some of the units of pressure are atmospheres, ATM, pascals, PA, kilopascals, kPa, and torrs. There are many others, but these are the ones that you would come in contact most frequently. The one that you probably are familiar with is pounds per square inch. On this slide, I give you conversions between the atmosphere and the torr, the atmosphere and the kPa, and the kPa and the PA. The third variable used to measure a gas are moles, and you're probably wondering why they don't use M. In other gas laws, we introduce mass, so M is saved for mass. So N is going to stand for the number of moles of gas, and remember, moles is a quantity, how much of something. Fourth and final variable is temperature, and temperature is going to be represented by a capital T, and as we said before, it's a measure of the average kinetic energy. Now, units that you can use for temperature that we've seen in the past are Fahrenheit, Celsius, and Kelvin, and we've used the following formulas to go between those 3 equations. You do not have to have those memorized. Whenever we use temperature in any gas law, okay, listen again. Whenever we use temperature in any gas law, it must always be in Kelvin. Now, we've talked about STP in the past, and we knew that that stood for standard temperature and pressure, but we never gave them a value, and that's what we're going to be doing here. If we ever say to you STP, that stands for standard temperature and pressure. Standard pressure is 1 atmosphere, or 101.3 kPas, and standard temperature is 273 Kelvin. So now that we have the 4 variables that we can use to measure a gas, what we need is some kind of equation that will relate the 4 variables, where we would only be required to measure 3 of those variables and then calculate the 4th. And how we do that is something called the ideal gas law. The law, the ideal gas law, is PV equals nRT. Now, we've defined PV, N, and T, and I'd like you to watch the following Edpuzzle and to fill out the questions. And then once you've paused and done that, to come back to this video. Okay, now that you've watched the Edpuzzle and filled out the information, we want to define R. I know they already defined it in the video, but again, I want to reiterate that. R is known as the universal gas constant. Now, when you think about a constant, you think that its value cannot change, and that's true. But the problem with R is that it has units. So if you change the units for pressure, volume, and temperature, then the value of R is going to change. Now, we are only going to use one value of R, just to make things a little bit more simple. So we are going to use the value of 0.0821 liters times atmospheres, so those units are in the numerator, divided by Kelvin times moles, and those units are in the denominator. So if you're going to use this value of R, you have to make sure that your pressure is in atmospheres, your volume is in liters, your N is in moles, and your temperature is in Kelvin. As long as you do that, then we are going to use this value of R. Now, let's see how to solve some problems. What I'd like you to do at this point is to pause the video and to click on the link of the Edpuzzle and to watch and complete that. Okay, now that you have done that, please try the following problems on your own. If you have any trouble, please come to office hours this week. Office hours weekly, unless I tell you otherwise, will be the following, and I will also post this on Classroom. Office hours for period 1 will be on Wednesday from 9 to 9:30. Period 3 will be Wednesday 10 to 10:30. Period 6 will be 11:30 to 12. And period 9 will be 1 to 1:30. Now, if you are unable to make your own class's office hour, you are more than welcome to join in any of the other classes' office hours. I will also have office hours on Thursday at 1:30 for anybody who may come up with another question, or also by appointment. You can either send me a text through Remind or send me an email, and I'll be happy to figure out a time that we can meet together. Okay, so please try these problems on your own, see how you do. When we meet for office hours, we'll give answers and we'll go over any problems that you could not do. If you feel you need any other extra practice, I have a tutorial site here which will give you as many problems as you need. And what I think you should be able to do is to get 5 correct so that you feel like you're proficient. Now, the next thing I'd like you to do is to complete the following problems. I would like you to show all work on a separate piece of paper, include your answer, and then I will provide feedback on those problems. If you wish to take things a step further, there is a great video or 2 great videos that have on Alka-Seltzer rockets. In order to do these rockets, you simply need a film canister, water, and Alka-Seltzer tablets. So I'd like you to watch the 2 videos at this point. Now, to get the greatest launch, you're going to have to consider your pressure, your volume, your number of moles, and temperature. And for the rocket to launch as high as possible, it seems to me that we would like to try to get our pressure as high as possible. But do we want the pressure to build slowly, or do we want the pressure to build quickly? So please watch the next video that may give you some ideas. If you do the Alka-Seltzer rockets, please take a video on your success and your trials and send them to me. I would love to see them. Have a great week, and I will see you at office hours and again next week. Thank you guys. Stay safe. Have a great day and a great week, and we'll talk to you next week.